Today we are continuing our work with Lesson 100 on quadratic equations and parabolas. Today we are going to do the first of two parts on quadratic applications, where we make connections between the equation and the parabola and what that means in the context of a given problem. We will be using our calculators, not on this very first one, but a little bit more. We will start doing these strictly on the calculator. So our first one for today, complete the square to find the vertex and graph. Is the vertex a minimum or a maximum? So remember, if we have a parabola that opens up, arrows on both ends, this one keeps going forever and ever up. So there's never a highest point, that the vertex is the lowest that the y can ever go, so we call that a minimum. And if we have one that opens down, it keeps going forever and ever. It never has a lowest point, it never has a smallest y, but it does have a biggest y, so this is the max up here at this point. So let's review what we worked on in lesson 100b, where we need to complete the square to be able to do this graph. So we begin by keeping the x's on one side, so the x squared minus 6x, and everything else goes on the left. So we have y minus 8. We take half of that minus 6, which is minus 3, and we have x minus 3. We want to square that whole parentheses, so we FOIL it out. X minus 3 times x minus 3 gives us x squared minus 6x plus 9. If we add a plus 9 on the right, we have to also add a plus 9 on the left. So that gives us y plus 1 equals x minus 3. To get it in vertex form, we subtract that 1 from both sides so that we have x minus 3 all squared minus 1. That tells us that it opens up, so we have one like this green parabola that I sketched, so we know already it is going to have a minimum. We also know by looking at this vertex form of the equation that the vertex is 3, the opposite of what's on the inside, the same as what is on the outside of the parentheses. So let me graph that over here, 1, 2, 3, 4. So there's my 3. I know that my x-intercept, let's do the y-intercept first. My y-intercept, I'll let x be 0, so I have 0 squared minus 0 plus 8. And my axis will be x equals that x-intercept, or that x-coordinate of the vertex, so it will be 3. If I wanted to get my x-intercepts, I could take this y plus 1 equals x minus 3 squared, take the square root to get rid of the square. This is a 0 for the y-intercept, so I'm looking at the plus or minus square root of 1, which is 1, equals x minus 3 without the square. Add 3 to both sides, which means that my x-intercepts will be 3 minus 1 is 2, 3 plus 1 is 4. So 2, 0, 4, 0. So my parabola must be looking something like this, with this being my axis of symmetry going through the middle of that one. So y equals x squared minus 6x plus 8. Still, y equals x squared minus 6x plus 8, so exactly the same problem, but this time let's find the x-intercepts by factoring, and then we want to verify that they do match what we got on example 1. So when we are solving by factoring, we change the y to a 0, and so two numbers that multiply to be 8, and that add to be negative 6, both positive or both negative, to multiply to get a positive. So 4, if we do minus 4 and minus 2, and that would indeed mean x is 2 x is for the very same x values that we got for our x-intercepts in example 1. So remember, x-intercepts, roots, solutions, and on the calculator, we know that the Inspire calculator calls those zeros. Okay, this one we're going to switch, and we are going to do with our calculators. We've done a little bit already, but doing a little bit more here. We're going to plug this into our calculator, and we're going to find whether it has a min or a max, and what that is, and the x-intercepts. So let's make a prediction. We have a minus in front of the x squared. So, up or down? This one should open down because it had that negative in there. So just to review how we enter this on the calculators, be sure you've written down y equals minus 2x squared plus 4x plus 3, so you can see that as you type it in on your calculator. To do a graph, we need to be on a graph page, either in Sketchpad or in a document. I'm just going to go to the Sketchpad. And then I have my function. Since this is y equals, I can enter it as a function. It was, oh good, we can still see it there. 2, and then the x, and then the x squared button is right beside the 4. Then we will have plus 4x and plus 3, and we will hit enter. Now this one is nice. I can see the whole thing pretty well on my calculator. If I had any trouble seeing it, I would need to be using the menu window and the 4-window zoom to be able to change the numbers or zoom in and out, whatever might help me get there the most easily. The other thing that I can do with the calculator, you can click on the numbers that are at the top or bottom of the visible part of the y-axis or the x-axis. And I don't think I really need to have it be quite this skinny, so maybe I don't really need to go as far as -10. So I'm going to click on it and usually click a second time so that it's kind of flashing in there. It's kind of a box within a box. And then I can simply delete that number, and let's type in maybe -5. And then I can move my cursor over to the +10 and do the same thing. And maybe let that be +5 and push enter. And all that does is spread my graph out a little bit to make it a little easier to work with. If this equation is in my way and I want it where it's not quite so bothersome, I can move it down to the bottom. So now I want to find 3 things on here. And this problem asks me to find the min or max, and the x-intercepts. We see this one is a max. It did indeed open down, so it has a max. And then I want to find, this is one of my x-intercepts, and this is my other x-intercept over here. So let's go ahead and get the vertex first. Best friend button is the menu, just like on a computer. When we aren't quite sure what choices there are, we take a look and see. And we want to analyze this graph, so you push the button 6, and once you push that, it's not a 0 that we're looking for. It's not a minimum on this one. Some parabolas it's a minimum, but this one it's up at the top, so we have to pick the max. And then it asks us lower bound, so we simply move that dotted line somewhere to the left of the vertex and click enter, and then move to the right, and it tells us that the vertex is 1, 5. Then to get the x-intercepts, best friend again menu. Again, we're still analyzing the graph. Now we want a 0, so that is choice number 1, so we push the button 1, and then we do the same thing, left of just that 0 and right of that. We can't go all the way over here or it's going to confuse the calculator. Only 1 0 between the double lines, and it gives us our decimals for that. And we repeat, menu, analyze graph, 0, left and right, and then we have the coordinates for the other one. If your calculator is not showing you 3 places, Best friend button again is menu. You're going to go to 8 for settings, and this one really should have been on float. I got lucky with this one that I got enough places, but I'm going to change it to float all the way up here at the top, and then I'm going to make that my default on here. Now I can write things down from that information. So let's see, my vertex is going to be 1, 5. When I round this left 0, it's going to be negative 0.581 to our 3 places, and the one on the right I will round to 2.581. So let's write that down on this problem. So what we would do on a problem like this, we would say it was a max, because we were asked that, and it was at 1, 5. And we would draw a quick little sketch here. Does not have to be completely accurate and to scale, but it needs to be close. So let me go back to the calculator and point out some things. The vertex, both coordinates were positive, so I must draw a vertex that is in the first quadrant. One of these x-intercepts was negative. It must be to the left of the y-axis. The other one positive. And notice, not as far past the y-axis on the left, farther past the y-axis on the right. That's enough of being to scale for our purposes on this. So a little bit to the left there, and then up here to a vertex, and out here, label that that vertex was 1, 5, and then we're going to label our intercepts. This one was negative 0.581, 0. This one was positive 2.581, 0. Most of these problems will actually have typed in there, draw and label a sketch. This is what I'm looking for. There may be a few where we forgot to get those directions added in, but it is always expected in this course. Okay, next one. Is that the next one, or did I skip one here? Pause for a minute. What happened to example 4? All right, sorry about that. Slides have gotten out of order there, but another one of these for us to practice. So we're going to use a calculator, so let's get our calculators up and ready to go again. Now, I've got all this stuff in there that I really don't want to look at, so menu, and let's see, we need to take action 1. And we want to delete everything we just put in there so we can start a new graph in there. So 4, and yes, we're sure we want to do that. So now we've got a blank screen to begin with again. And then we are going to tab so that we can enter our function. 2x, and then we're going to square the x, minus, now we are subtracting 8x, and then plus 3, and enter. And there is our graph. Looks like that one's in a pretty good position. I'll just move that equation out of the way, and we will find the max, min, or the max or min, and the vertices, or the zeros, the x-intercepts on this one. So menu, analyze graph, and this one has a minimum. It has a lowest point. So we go to the left and the right. There's our minimum to negative 5. Menu, analyze graph. Zeros now for our x-intercepts go somewhere to the left of it, to the right of it, and we have those coordinates. Once again, menu, analyze graph, 0, left, right, and here are the coordinates for the other x-intercept or 0 on this graph. Notice both of these are positive. Notice the vertex is positive, negative. Once in a while, your window may be so stretched out or so zoomed in or something that maybe you didn't have the right scale on it, and it's very hard to tell. Maybe it almost looks like it's on it. Once you get the coordinates, look at them, positive, negative. I must draw a picture where it looks like that is in the 4th quadrant. So let's get all of this written down on our graph. Let's see, we need to round those to 0.419. 8 followed by another 8 rounds up to 419, and 3.581. And again, the minimum, the vertex was 2, -5. So here is our little sketch for that. And we are going to have a couple of positive y-intercepts. This was 2, -5, and it was a minimum. This intercept was 3.581, 0, and this one was 0.419, 0. Pretty easy for today. But some of them will start being word problems, like this next one, just to give a little more challenge and let us start to understand how this might help us in real life. So we have a small business, and they've run some computer analyses, and the computer has come up with, this is the model for how much profit they made each week in a year. So y equals -0.555 x minus 12 squared plus 630. So week 1, they made -0.555 1 minus 12 squared plus 630. Week 2, they made y equals -0.55 2 minus 12 squared plus 630, and so on. So we want to know, well, what's going on with that? Does it have a maximum or a minimum? What is that value in the context of the problem? What does that maximum represent? So let's get our calculators here again. Once again, we need to clear them. So menu 1, 4, yes. And then we are going to type in our equation. So we need to hit tab. And this is a -0.55. Then I need my parentheses. So I go to my parentheses button. Inside the parentheses, I need x minus 12. X minus 12. Then I need to go outside the parentheses and square that. And then what was the other part? Plus 630. So plus 630. Enter. Wait a minute. Where's my graph? Oh, now wait a minute. Let's see. I'm going to guess maybe my parabola is way out here outside this window or something. So I need to fix that. So let's go into menu, graph entry, or window zoom, and we can just try guessing some if we pick window settings. We can try zooming in or zooming out. I'm going to hit zoom standard first just to see what happens. That didn't really help. So I'm going to try it again. Menu, analyze graph, or no, I'm sorry, window zoom. And let's zoom out and see if we can find the thing somewhere. And then I'll want the center. Well, I think maybe it's here. Let's keep going. I'm starting to see it. It looks like maybe here's one side and here's the other side. Looks like maybe those are starting to tilt in a little bit as I go up. Oh yeah, that would make sense. There's a negative out in front of the parentheses, so I'm kind of thinking that it's going to open down. But let's keep zooming out for a while longer. And so now what I'm getting is, okay, I think I need to make that top number go quite a bit higher. So I'm going to escape so that I can quit just hitting center. I'm going to click on this, and let's see, let's try, oh, I don't know, let's go up to 1,000. Maybe that's going to be too far. And so let me enter 1,000 and see what happens there. Okay, now I can start to see. It does look like I didn't really need to go that far. And just to have more room to work with, I don't really want to go quite that far. So let's maybe go to -50 and see if that helped. And this one, maybe let's try +50. I didn't really want to go, that's a little bit close for getting those zeros, so I'm going to try changing it again here, if I can get back to it. And it's not quite wanting to let me do that, so let's see. Now it will, I think. There. So let's go maybe 75 there. All right, so now what were we asked? Does it have a maximum or a minimum? Well, it opens down, so we see that it does have a maximum. What is that value? So here's what we do with that. Menu, analyze graph, max, left, right. Here are our coordinates. 12, 630. So this graph has a maximum, and it has a maximum at 12, 630. We are asked, what does that mean in the context of this problem? So that's when we have to stop and think about, well, what are these variables? So the profits in dollars for X weeks. So our X's are weeks. And the profits are in dollars, so that means our Y's are the profits in dollars. So X was the weeks, or the point is always X then Y, so this is the profit in dollars. We expect you to write a complete sentence where you are writing everything out. So what you would do is you would say that the maximum profit, because the max is what is the highest Y? The Y is the profit, so the highest Y, in this case the highest profit, is $630, must have units. It's okay to use a symbol or an abbreviation for units only, everything else complete words, and it occurs at 12 weeks. And that is our model. Be sure you've copied it down so that you know what we are looking for. And then let's think about what that might mean for a business. So, before they ever start making and selling anything, a company has some expenses. They have to buy machinery, they have to buy or rent a place to make the product. So they have expenses before they ever get started. So that would be like our y-intercept. Y is when the weeks are 0, times 0, they haven't actually gotten started yet, but they've already had to spend some money to get ready to get going. Then the weeks start going by, week 1, 2, 3, as we go along the x-axis here, and they start selling, and they get a little bit more efficient, and more people hear about their product and want to buy it, so profits go up. But at some point, maybe the profits start to taper off a little bit. Maybe other companies have caught on and they start making something similar. Maybe the people that most wanted this kind of product, that were most eager to get it, have now bought it, and maybe there's not quite such strong interest out there. We don't really know the cost, but that's the kind of thing that might be going on, just to let me help you make a little bit of sense out of these kinds of problems. So now I need you to get that sheet of paper that says Quadratic Application Problems Part 1. It's one of the smaller sheets of paper, and that is your homework assignment for tonight.